In last lecture, we have seen how to find characteristic equation of a 2 by 2 matrix with the formula determinant of A minus lambda I is equal to 0. Today we'll see alternative of finding the same. So if you just have a look the of the last example, this was A 230 minus 1. This was the characteristic equation, and these were the eigenvalues of A that we computed. Now just try to observe that trace of this matrix is sum of the diagonal element, and in this case it is plus 1, and determinant of this matrix is minus 2, and those coefficients of lambda and constant term, if you observe in this equation, that we can connect with these two values, trace of the matrix and determinant. But trace is positive, so here if I just compare lambda square minus trace of the matrix into lambda and plus determinant, and now the determinant is with negative sign, and determinant itself is minus 2, so this becomes minus 2. Or instead of writing in terms of trace and determinant, we also write this characteristic equation of 2 by 2 matrix lambda square minus s1 lambda plus s2 equal to 0, where s1 is trace of the matrix and s2 is determinant of the matrix. If we generalize this concept or this formula to 3 by 3 matrices, the characteristic equation is given by lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0. So let us understand what those s1, s2, s3 are. So in this case, s1 is again trace of the matrix, which is sum of diagonal elements of A, and now s2 is sum of principal minors of A of order 2. So by principal minor we mean minor of A11, then minor of A22 and minor of A33, their sum. And as you recall, minor of Aijth entry is determinant of submatrix when ith row and jth column from that matrix is excluded. And S3 is determinant of the matrix 3 by 3 matrix A. And again you can observe signs are with alternate plus minus lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0. So for 2 by 2 matrix, we use this equation to compute characteristic equation. We use this formula to compute characteristic equation, and for 2 by 2, we use this formula. Thank you.